Hello. Today we are going to continue on weekly contest 329. So the last problem is minimum cost to split an array. So what the problem says is basically we get an array of numbers and we get an integer k. And what we want to do is split the array into some number of non-empty subarrays. And basically we have a cost. The cost of splitting a subarray is basically the sum of the importance value of each subarray in that split, right? What is the importance value? The importance value is just about, first, it's k plus trimmed subarray length, right? But what is trimmed? By trimmed, they mean basically removing all the numbers that appear only once, okay? And the final goal of the problem is to return the minimum possible cost to split the list of numbers, right? So the minimum possible cost to split the numbers, okay? And let's take a look at an example here. So we have this array k equal to 2. So we can split the array with, for example, this version here, and that will give us the importance for this one would be k, which is 2, plus 0, because there is no, all of these 2 will need to be removed because they occur only once, right? And so the importance value would be 2. And the importance value for this other, the rest of the split is going to be k, again 2, plus, what is the trimmed array? The trimmed array is going to have 1, 1, 3, 3, because they occur 2 times each, right? And so the length is going to be 4, right? And so 6. 2 plus 4 is 6. So this is the importance of the second one. And so what is the total cost? Total cost is going to be the sum of these two, and that's 8. And this is, if you try other variations like this one, for example, and this one, maybe try this one and this one, you will find that 8 is the minimum. And so this is what we return, okay? Okay, so let's just take a look at the constraint here. So we have, the length can be up to 1,000, right? So 10 to the power of 3, right? So this immediately tells you that if we do an algorithm that is O(n) squared, which is going to be 10 to the power of 3 by 10 to the power of 3 is going to be 10 to the power of 6, that should pass fine, right? But anything above that, let's say maybe we do cubed, then that's going to be 10 to the power of 9, so it's not really going to be feasible, right? So let's see how we can solve this. So the first thing to think about is, okay, what are we being asked to do? So we are asked about the min, let's just jump here a little bit. We're asked about the min cost, right, to split the numbers, right? So what does this mean? So this is basically, if we, with dynamic programming, we want to at least either express it in terms of, like, because this is a minimum optimization problem, and it doesn't look like there is any greedy approach we can take or anything like that. We should think about, okay, how do we divide this into some sort of either a problem expressed in terms of subproblems. So either those subproblems can be prefixes, they can be suffixes, or they can be maybe even like I to j thing, right? Okay. What this means basically is that what would be beneficial when we are at some position? Would it be more beneficial to know what's before, or would it be beneficial to know what's after, right? Okay, and so here, let's try with the suffix approach, right? What I mean by that is let's maybe say that the function dp of I is going to be the min cost to split starting at I. So the suffix approach to the end, okay? And what this will help us with is that when we are at I, when we are at some position j, we would already have computed for j minus 1, okay? So what would be the result that we want to return at the end? Well, we want the min cost for the entire array, so what we want to return at the end is dp of 0, right? So this is basically the goal that we want to calculate. Now, what would be a valid recurrence relation and what would be a valid base case, right? Let's focus first on the crux of the problem, which is what would be a valid recurrence relation to use here. Okay. So when we are calculating for dp of I, right, which is the min cost to split at I, what we should do basically is just try all the possible splits after I, right? So let's say here we have our array and this is I, okay? And we want to calculate the cost, the minimum cost for splitting, the minimum cost to get the split with the minimum cost for the rest of the array, right? So let's just try all of them, right? Let's just try I plus I, try splitting here, try splitting here, try splitting here, try splitting here, and take the min, right? And the other thing is that on each call of this, it will consider splitting next on this one, or next this or this, and so we will do all the possible splits, like this one and this one's this split and this split, and maybe this split and just one element left, and you get, or this one and this one, and you get the idea, right? So we'll try all the splits and we'll just take the minimum of them, right? And so what would that look like in terms of code, right? So that will be something like for j, which is the rest, it's going to be all possible splits from I to the n. So it's from I to n. Okay, and what do we want? The min cost for I is going to be just the minimum, whatever cost we had from a previous other split configuration. And this split, what's the cost of this split? Well, the cost of this split is just the importance of up to j plus the cost of splitting at j plus 1, right? The cost of splitting starting from j plus 1. Okay, let's a little bit focus on this formula a little bit more so that we make sure we understand it. So I'll just copy it over. Okay, let's focus on this formula a little bit more. Okay, so what does this mean? So we have this array, we are at this I position, right? And we want to split at some j position here, right? So naturally then what we want is we want to get the importance of this because we split there. And then we want to get the rest, the minimum cost for the rest. And the rest is just dp of j plus 1, right? And we can add these together, okay? And since we will try every possible split, we'll do it for each one of them, okay? Now the problem becomes, how do we calculate this importance in an efficient way, okay? The thing is, you can see in our loop here, we are going from left to right. So we definitely can like calculate the importance with a event time loop, right? But we are already looping here from left to right, okay? So let's take advantage of that and not recalculate basically O(n) each time. So let's just, every time we add nums of j. Let's say j was equal to 2 before, then at this point we would have calculated the importance up to j, and then when we are at j equal to 3, just figure out by how much would we add to this importance when we add the number at position 3. That's all we need to do, right? And so how do we do that then? Well, there is one observation that we need to make, and that observation is that basically, let's say if you have, so the importance, what is the importance first? So the importance is initialized to is k plus the length, so the trimmed array length, okay? Now this k is just the initial value, so we can just initialize the importance at k first. And now what happens? Now we just need to observe what changes for the trimmed length, right? So let's say we had a subarray 1, 3, and the number at j is equal to maybe 3. So what would happen in this case? In this case, the trimmed length is removing those that occur only once. So the trimmed one is going to be just empty. So when we want to add this one, what happens? Well, the list is now 3, 3. So the trimmed one needs to be 3, 3, right? So you can see the length increased by 2. And so here, the trimmed length basically increases by 2 if, right, if the occurrences of a number at position j are equal to 2. If they just became equal to 2, that means we are, in this case, basically there was just one instance, so we weren't calculating it in the trimmed version, but now that we have 2, we should count both because the length becomes 2, right? So we want to increment by 2 if the number of occurrence is equal to 2. Of course, this is after incrementing the number of occurrences of j. And so you can see here already we need a counter here for the number of occurrences. So that would be something we'll need to define here and just keep updating it as we go through j. So this would be the just a counter or a map if you want. Okay, so what's the other case? So this is the first case. What would be the other case? The other case is that, let's say we have, okay, let me clear it up a little bit. Clear this. Let's say we had more than, let's say we had already 3 here, right? Okay, and the number at position j, let's say it's equal to 3, right? So here, the trimmed was 3, 3, right? And now we want to add, so the length was already 2. So what should be added? So now we just add 3 third time, but since they already occurred 2 times, that means the trimmed length is like this, okay? And so what is the length? It's 3. So by how much we should increment? Just by 1. And even if you had, let's say, 3 3s and you have a 4th one, you would need to increment just by 1, right? And so this means basically that we need to increment by 1 if the occurrence after incrementing the occurrence, of course, after incrementing it is going to be, if the occurrence count was bigger than 2, then 1 increment by 1. Now what if it wasn't there? It's the first time that it's appearing. What should we do? So let's just clean this up a little bit, remove it, and see what happens in another case. So let's say we had just 1, right? So if you had just 1, then the trimmed was empty. And now let's say our number at j is equal to 3. In that case, what should happen? Well, the list is going to be 1, 3, right? In the occurrence counter, right? So the format, of course, is going to be 1, 1, 3, 1, okay? But the trimmed length doesn't change. It's still 0 because this is the first time it occurs, right? And so in the else case where it's the first time it occurs, so this would be else of these 2, then we do nothing. We add nothing, right? So 0, we add 0. So no increment, basically, let's call it. Okay. So this idea here, this piece here is important in terms of the calculation of the importance in a linear way, right? So here we'll just do the logic that I mentioned in the formula here. Okay, so those 2 things actually are the only ideas we need, and then we can just do a recursive DP and cache the result. What are the 2 ideas? The first one is calculating the min cost this way, where you try all possible feature splits, and then you just take the min. But then since we need the importance, we want to calculate it in a way that it's not linear each time, because if it's linear, then it's going to be O of n squared, and then add that on top of all the i's that we'll calculate it for, it will be O n cubed. So we want to calculate importance in a way that we maintain this to be O of n. This at least loop to run only once. And so to do that, we will just use this trick here of figuring out by how much we need to increment from the previous state. from the previous value of the importance. So at j, we want to just figure out by how much we need to increase the importance vis-a-vis of the so basically when we are at j, we just need to take the importance at j minus 1 and see with the new number by how much we need to increment it, right? I hope that was clear. And that's pretty much it, right? And so with these two, we should be able to code a solution using dynamic programming. Yeah, so let's get to it. Okay, so let's implement what we saw in the overview. So what we need here is we just need to do a function for our DP, right? So this here would mean basically the minimum cost starting at I to split array starting at I, okay? And so what we need to do then here is call it, right, for 0, and that's what we return, because we want the minimum cost split array from 0 to the end, right? And so here, let's just get the length of the array. And then what we want to do here is, of course, for our base case, if I is equal to n, then we are done. We just return 0. There is no cost after that, right? Now comes the interesting part. So here we need to go through j from I to n, and we want to try all subsequent all splits after that, right? And the importance starts out as k, because remember, it's the rule is that the importance is basically k plus the length, trimmed array length, right? And basically, so we'll initialize it with this so that each time we just figure out the only thing that will change is the trimmed array. So when we add a new number, when we are considering a new number for j, we just check by how much it will increment the trimmed array length, right? So that's why we initialize at k here. And then how do we check if by how much it increments this? We need to keep track of how many occurrences we've seen of each letter, right? And so to do that, we are going to say a collection here of occurrences. So you can use a map, but I'll just use like a counter here in Python. It's easier. And so when we encounter a new number, we want to increment that it increase it. And remember the rules that we mentioned in the overview, which is that if the occurrence just became 2, that means we just added 2 to the length of our trimmed array, because now they are duplicates. Before it was only one instance of it, and so we want to increase the importance by 2 in this case, because we just added 2, right, to the trimmed array. Otherwise, if the number of occurrences is bigger than 2, that means there were 2 before, and we are just adding an additional 1, so we just need to increment the importance by 1. But if it wasn't before and we just added it so it's equal to 1, then we shouldn't add it because it won't be in the trimmed array, right? So that's the idea. Now what we want to do after that is basically just the cost, get the min for the cost, right? So we need the cost here. Since we are going to take the min, we need to use a large value so that any value would be set here that we get from any j. And so what we want here is just use math infinity. So this would be just really large value. So here what we'll take is the min, is the cost. You can, if you prefer, you could call this cost of I. And the importance up to j, so this is going to be the importance up to j plus the dp of going for the rest of the array, which is j plus 1, right? And that should be it. And so at the end, we just want to return the cost for I. So let's just call this cost I. And of course, we want to, since this is dynamic programming, we want to cache it. But first, let's just make sure it passes test cases. And looks pretty reasonable, looks good. So we will of course get time limit exceeded because of we haven't cached it. So we will do repeated calls to the same indices. And so the easiest thing you can do is just create a memo table. So of course we get that time limit exceeded. And here what we can do is just, if I is in memo, then we just return memo of I. And then here we want to set memo of I to be equal to the cost. And we want to return, of course, that cost, okay? And with this, let's submit. So this here is just adding caching, so that if we've seen it before, we don't recompute it. Looks like that still is slow. Yeah, so actually here we are just missing this return, and so let's run this again. Sorry about that. I'll submit, and this passes our test cases, right? Okay, yeah, so pretty straightforward. The main two things to notice is that you can do it in a suffix way like this, and then the other one is this part here about how do you calculate the importance basically as you increase j without recalculating it each time. Okay, yeah, I hope that was easy to understand. The other thing I want to just quickly mention here is that you can get rid of this memo when we are doing Python, since more idiomatic to just use this cache function here that I have. Yeah, basically it's just add the cache function here and they should work fine. Get rid of all the memo stuff, run this, submit. I may have had it when I had the memo, but we don't need it when you use a memo map, right? And that passes as well. Yeah, so that's pretty much it for this problem. Please like and subscribe. Consider supporting the channel on Patreon, and see you on the next one.